Every day, 120 people in the United States die due to drug overdosing. Furthermore, 81.1% of all drug-related overdoses in 2013 were unintentional. And even more people are hospitalized every year due to drug overdosing or even underdosing because they don't follow their prescription. Standard pill bottles are not the solution.
The solution is Adera, the smart medicine pill bottle management system. It allows doctors to keep track of their patients' medicine usage over time. Adera is named after the Romanian word for adhere because it addresses the problem of medical adherence, or patients following their medical prescriptions.
This is the bottle that each patient has, and this is a website that the doctor uses in his hospital. And whenever data is sent from the bottle to the server, the website gets updated automatically with the new number of pills. And so, if I remove the prescribed number of pills, which in this case is 3 pills, and I put the cap back on the bottle, the website gets updated automatically with the number of pills left in the bottle. And so, whenever this happens, a doctor can see and make sure that the patient is taking the correct number of pills. However, if the patient takes too many pills and overdoses, taking a lot of pills, and then I put the cap back on, as you can see, there's now a big red bar indicating that the number of pills is very low. And the doctor can see that the number of pills changed from 38 to 13, which is not a good sign, as their prescription only counts for 3 pills. And so whenever this happens, the doctor can automatically call the patient or even their family to alert them of the issue and find out what's going on.
Adera's primary application is allowing doctors to monitor the medical adherence of their patients. As we have just demonstrated, doctors are notified whenever patients are consuming their medications. Thus they can tell whether they're taking too many or too few pills, or whether they're taking them at the correct frequency or times. When patients are running low on medication, doctors can order more pills for them so that they never run out. There are other applications of Adera as well. Family members could be given access to the Adera website so they can keep track of the medication usage of their loved ones. So if they are running low, or if they're not following their prescriptions, they can call or text them to ask them what's going on. And finally, pharmacies could use the same technology in Adera to keep track of their inventory of medication. If they are running low, Adera could alert them so they can order more stock so they're never out of supply.
The website is the primary method by which a doctor or anyone else can monitor the medication usage of a patient or a loved one. And more specifically, the device that powers the server behind the website is the Raspberry Pi. The Raspberry Pi is a low-cost and very powerful device for our application. It's essentially a mini computer. And the technologies that we're using to power our entire system are, on the front end, we have HTML, CSS, and JavaScript, which power the entire user interface. On the back end, we have Node.js, which handles all the data communication between the server and the bottles. And then all the data is stored in a MongoDB database. We built the entire Adera system to be very robust. What this means is that we can easily add on hundreds more pill bottles automatically to the server with no extra cost to our existing code.
There are 3 main components in each Adera bottle: the spark core, the weight sensing circuitry, and the cap sensing circuitry. The spark core, located in this side chamber, is the brain of the bottle. It is a microcontroller similar to an Arduino, except it has built-in Wi-Fi capabilities. It is programmed in a C-type language called wiring. Next, the weight sensing circuitry allows the bottle to measure the weight of the pills. As you can see in here, there is an inner chamber where the pills are stored. Underneath that chamber is a load cell that outputs an analog voltage proportional to the force of the cell. This signal is boosted with an instrumentation amplifier and then received by the spark core. Finally, the cap sensing circuitry allows the bottle to determine whether the cap is removed or not. Underneath the cap is a series of magnets. When the bottle is closed, the magnets come in close proximity to a reed switch, which closes and thus outputs a signal to the spark core. Then when the cap is open, the reed switch opens and this signal is disconnected. Thus, whenever the cap is opened and then closed, meaning the patient has likely taken out some pills, the spark core is temporarily awakened. It reads the output of the load cell, it calculates the number of pills, and it transmits the information over Wi-Fi to the website. It then goes into a sleep mode, allowing it to save battery while it waits for the patient to open the bottle again.
Adera began with a simple idea. From those initial roots, it spread in many different directions. First, we created individual components to test that our ideas were valid, and then combined those together to create our proof of concept. First, we created our reed switch circuit, and then our load cell circuit, and then tested the spark core by itself. Once we confirmed that each of these individual circuits and components were working, we were able to integrate them together into one initial prototype bottle. And when this bottle worked, we were able to confirm that our idea was valid, and we were then able to move on to the next stage of development.
This next stage was to improve the reliability, accuracy, and aesthetics of the bottle. We accomplished this by 3D printing our own bottles that would resemble the final product. We first started by designing the individual parts using a computer-aided design software called Autodesk Inventor. Then we combined all the individual parts into a single Autodesk assembly. This allowed us to test whether the different components fit correctly, and also allowed us to perform stress analyses that we used to determine whether the bottle would be stable under the different forces. Once the parts were all finalized, we 3D printed them using a MakerBot 3D printer and assembled the bottles.
We also developed our website concurrently. And with this process, we started from an initial version, which simply proved that we could receive data and display it to the user. From there, we added in database integration, and then increased the user interface and the user friendliness.
In the end, we had a completed system and achieved what we set out to do.
Namely, the creation of the pill management system that would solve the problems of today.
Thank you.